6.3 Numerical Model. A numerical model is another model we can use to analyse sports performers to highlight what they need to improve on. This model focuses on the kinematics and kinetics of the given sport, so it looks into the motion and forces on the player. Kinetics are the forces that are applied, for example, a push in a basketball shot. Kinematics refers to the motions or movements, so it looks at planes and movements. Because of this, it is a more qualitative approach, meaning that it is more objective as we're looking at numbers and stats as opposed to people's opinions on what the performer should be aiming for. Similarly to other models, this is created using a range of different data as we can compare to professional athletes, group averages, and the best performers in your group to show your performer what they are weak at and what their strengths are. You can also use specialist research that's literature, like a journal for example, which will show what other performers have got. It is important when using these that standardized data is used so the tests are carried out the same so that the results can be compared. There are three types of motion in sport: linear motion, angular motion, and general motion. Linear motion is the movement in a straight line across one plane of movement. This is not usually seen in sport, as this type of motion is where all movement is in the same direction and speed, which would not usually happen in sports like basketball, for example. This is usually seen in events like the skeleton or bobsleigh, as they would at points be moving in the same speed in the same direction. The next motion is angular motion, which is where a body moves around an axis, whether imaginary or for a bar in gymnastics, for example. And because of this, the body moves in the same direction, time, and angle. Finally, general motion is a combination of the two, as in general motion both angular and linear motion occurs. A projectile is quite self-explanatory, as it is an object that is projected/moved by an applied force. For example, a shot put is a projectile, as it is launched by the force of a push into the air and forwards, which is then brought down for its mass and gravity. This is the same for a basketball. Scalars and vectors. A scalar is a value that has a magnitude with no direction. There are therefore many scalar quantities within the sport of basketball. For example, distance is a scalar quantity, and it is very useful to look into as it will show how much the performer is running during the sport. Another quantity is speed, which is very important in basketball when sprinting end to end, and is therefore assessed as well in the numerical model. Vectors, on the other hand, have both a magnitude and a direction, so quantities like force and acceleration would fall under this, as a force shows the size of the force, magnitude, and the direction it is acting. And similarly, acceleration shows how quickly the player is accelerating and in what direction they are moving in. Both of these are important in basketball as forces and acceleration act on the ball and the performer. One part of linear motion is distance and displacement. These, although similar, are two different things, as distance is the total a performer has travelled from every step in the route they took, whereas displacement is the distance between the starting point and the finishing point, point A to B, the direct route, involving the direction, meaning it is a vector quantity, unlike distance, which is a scalar quantity. This can all be seen in the image above, which shows the direction and displacement. For example, it's clear to see the distance from point A to B, in this one, is much longer than the displacement. In this case, the distance could be 500 meters, for example, and the displacement could be 200 meters, despite them starting and ending at the same point. As said previously, this can be important in determining and comparing to the numerical model to see how much to see the distance travelled by a player. These can also be shown on the graph above. As you can see, in part A the person is moving at a steady speed, moving 8 meters in 4 seconds. The straight line in part B then represents the person being stationary and not moving forwards until 7 seconds, where they return to the start at a steady speed. This is the distance time graph. Speed is a scalar quantity as it involves a magnitude with no direction, which shows how quickly a body moves in a given amount of time. Typically, we'll calculate the average speed, as no player will travel at the exact speed for a given period of time, as they need to accelerate in order to reach their maximum speed during a sprint. This can be calculated through finding the distance a player has run and dividing it by the time it took them. The equation can then be rearranged to find distance or time if the other two values are known. Players can calculate their speed for a 20-meter run, for example, through time and how long it takes to reach the finish line, and using that figure to divide it by the distance. However, you could also calculate the speed in intervals of the sprint to see how quickly they are moving during the 10 meter to 15 meter period of the sprint. They can then compare it to the group averages or the better players to see if this is something they need to improve on. Overall, speed is how quickly a player is moving or how quickly a projectile is moving across a given distance. There is also velocity, which is very similar to speed, however uses displacement as opposed to distance in the equation. Because of this, it means it is a vector, as it is effectively how quickly a body has moved in a direction. This will be measured in meters per second. For example, this can be used to measure the speed and direction of a player passing the ball or sprinting towards a certain end. For example, both speed and velocity can be shown in graphs. For example, a speed time graph can show how quickly a player is moving over a certain period. A steep positive gradient would mean they're speeding up, and likewise a steep negative gradient would mean they're slowing down. A straight line in this graph would represent that they're moving at a constant speed. Many of these scalars and vectors can be illustrated in a distant time graph, which looks like the image in the PowerPoint above. On this graph, the x-axis represents the time taken and the y-axis represents the distance, which we've been through before. These graphs are very useful, as once constructed they can be used to show us a number of things. For example, using any 2 points on the x-axis, we can determine the speed of a performer, as we can use the difference between the 2 points to calculate the time taken, and the point in which it would hit the line vertically to calculate the distance, which are the two factors needed to work out speed. In addition, you can compare performers by plotting numerous lines on the same graph to perhaps see who completed a certain distance the quickest, and see how they did that, whether it was for a steady speed / constant velocity, or if the speed changed throughout the race. This leads us on to the next points that can be made about a distance time graph, which is that it can also be used to show acceleration and deceleration. This would be represented with a curved line. If it is curving upwards, this would show acceleration, as the distance is increasing per unit of time, meaning the gradient is increasing, which represents speed, and therefore proves that they are accelerating. On the other hand, the curve could begin turning downwards, suggesting there is deceleration, as the distance is decreasing per unit of time, meaning they are beginning to cover less ground within each 10 seconds, for example. Furthermore, a horizontal straight line, no matter of the y-axis, would represent that they are stationary, and would have zero velocity at the time, as the time is increasing but the distance is not. Velocity time graphs, however, are more useful to represent changes in acceleration. This is because the line illustrates the velocity, meaning if there is a straight line, there'd be no acceleration, as the velocity hasn't changed, but does not mean the body is stationary like it would represent in a distance time graph, as it is still moving unless the velocity is at zero. If there is a decrease in velocity, this would mean that there is deceleration, and likewise, if the velocity line increases, there is acceleration. The steepness of the curve will represent the extent of the acceleration, because acceleration is the rate of change in speed or velocity. This means it can be calculated with the formula change in velocity over the change in time. However, a change in direction can also affect velocity, as it is a vector. For example, a basketball runner may be running to one end at a constant velocity, and would therefore have an acceleration of zero. A change of plane may then cause the performer to turn, which would decrease the velocity and therefore decrease acceleration. Increase deceleration until the last push against the floor from the foot, which would increase the velocity in the negative direction, and would then build up as they begin to run as a negative value. So basically, acceleration is the change in velocity per second, and represents if a body is speeding up or slowing down.